All right, so I'm live. So, just working on data structures and algorithms. I guess just like everyone else, or most people, or let me not even say most people. I would say some people right now in this job market who are facing like duress, not really landing any opportunities. Like I feel you. I've been going through a slew of interviews for like data analyst roles, analytic engineering roles, business intelligent roles. I've been getting interviews. I know some people haven't been getting interviews at all, so I'm just blessed to even be getting interviews. I haven't really gotten anywhere other than that. I've gotten made it to the second round of interviews. I can admit I bombed some. Others I think I did really well. I haven't heard anything back. Essentially just ghosted. And I think the market we're in right now is really definitely inflated to keep really the S&P to, to to continue to grow. Um, I think now people are starting to um, feel the tightening pressure from a macroeconomic perspective. So it's people from multiple states in the country that are feeling this pressure. And it's just not coming from the tech sector now. It's coming from a lot of different areas, which is which is forcing the Fed's hand right now to really just lower interest rates, which is a positive thing for housing. But it is going to obviously slow down the S&P 500. We've been on amazing growth, and it's going to, to continue to grow. But in order for it to grow even higher, it has to cool down. It has to exhaust, and then it'll build back up again. But all that's leading me to really just want to practice the fundamentals, ingrain the fundamentals into me like it's the Bible, like it's the Quran, like um, data structures and algorithms. Just from just reading and understanding and just big O and just complexity, space, memory, and how efficient like is the algorithm, and understanding what algorithm to use for a specific task. Like I think all of that plays a key part in just not being a software engineer, but just a overall well-rounded technologist. And I want to understand and know what I'm doing. Right? It's like I can put together something. I could put together an LLM and essentially make it do what I want to by just plugging and placing, watching a whole bunch of tutorials. But if I don't really understand like um, not just the math, but understand actually how to code, right? Like understand how to to make the computer do what I want it to do. I don't feel like I'll get really far, and I'll just be in this place where I'm like, okay, like none of these companies want to hire me. None of these companies want to hire me, and I understand like there's a lot of ghost jobs as well. Like I'm not taking that away from anybody, but in order for us to just really get to the point where we're able to command what we want to do, we have to be experts or we have to be very specialized, right? Wait till that plane flies by. You just have to have a growth mindset and do everything you possibly can to like get to that next level and whatever that next level looks like for you. And for me, it's actually understanding what the fuck data structures and algorithms are, how to use them, so I can be able to do my projects more efficiently. And then not only just DSA, but um, understanding understanding how the top tier 1% engineers, how they work, how they function, how they think, how they process information, and just trying to replicate that, right? So we can, get similar results or try to replicate and get similar results. And so for me, the way I learn best is by typing. and doing things repetitively. Of course, that's how everyone learns. But for example, for a math question, the way I learn math is by writing the question about 5 to 10 times, right? That's how I learn the question. And it's not with every question, but if it's a question I don't know, I have to write it down over and over again until I understand the pattern. And just going through just the DSA course right now, I just see there's patterns in these things, and so it just brought me back to math when I was in school, just writing it down or repetitively. Right now we're getting to increments, and so this is a simple for loop. This is the for loop with increments. I feel like I should play some music, but actually I know what I'm gonna do. Mm, let's see the new. So I like again. I just like keeping up with domestically, just our macro, um, our economic market from a whole, really from a housing perspective, but as a whole as well. Let me see. This is Amory. I guess we could listen to more. This type of, and then I use like, I mean, this one I don't necessarily understand, but I'm gonna see that a little bit later. I need to focus on this. Print X. Let me see what it is. So X is set equal to 100. So first, this should print. Okay, so I see. So I'm gonna delete for X in range. Let's just say we're gonna start at 2. Let's just say we're gonna start at 5. In, and then you make K. Let's say, let's say 5. Okay, and then oh, and then it's print x, right? Wasn't it print x, and then x equals 100, and then print x. And so we should have from this 5, let's start at 5, 10, 15, 20, 25. And why is it just 5? So, oh, so should I make this 25? Oh, I should make it 30. Okay, that makes sense. And so this one, so it says the explanation with this Python statement, x is initially set equal to 1, and then gets set to values incremented by k until it reaches a number greater than or equal to n. Okay. So n always has to be greater than k. And then doing simple nested for loop. And then we're just going to set for I and range n for x and range m. Runtime O and m. Constant. So this is why if it were something like if I or m set or or n was set to 5 and m was set to 5, then it would just be 25. Um, um, and then nested for loop with so range n for x and range I. Nested for loop with dependent variables. Consider individual. And so this will be of n squared. Run time is n squared. The outer loops n times, and for each time the outer loop runs, the inner loop runs I times. So the statement in the inner loop do not run at the first iteration of the outer loop since I is 0. Then they run once at the second iteration of the outer loop since I is equal to 1. At that point, they run twice, then thrice, until I is n minus 1. And so they run until the iteration is complete, or the reach end of the index of n, till they then it stops. Of course, the iteration stops until it runs to the tail the tail of the nth node. Could you say that? I'm not sure. So they run a total of 1, 2, 3, 4, 5. Yeah, it's depending for I and so the nested for loop with index modification for I in range in I multiplication equals 2. So just the same, like minus equal plus equal 1 or 2. Now we're just multiplying it by 2. And then for x and range I. So of course it'll be the same thing. It's pretty much the same. Oh, I didn't even do that. Oh. So the nested for loop with index modification for I in range n, for the elements in the range of n, multiply that by 2. For x in range I, statements that take no sense. I'm not going to write it over again. So that means that the constant time statements in the inner loop are one of a total 0 plus 2 plus 4. So plugging this into this to make sure. Wow. Is less than n, or I is less than n. I. Okay. Do I put the while right here? I'm not sure where I put the while. I is less than n. So I'll just put it right there. And then I'm just going to say loops with n time x study. Oh, okay. It loops them that multiply, six variables, but Challenge. Big O of nested loop addition. Compute the big O complexity of an algorithm which involves nested loops, where the loop variables increase with addition. Problem statement. Compute the big O complexity of the code snippet given below. It is better to solve it on a piece of paper than see if answers match. So O of n. Yeah, I feel like it was O of n squared because of the addition. Mm. Solution. I want to write this. So we have n equals 10. We have sum equals 0. We have pi equals 4. For I'm just going to say I and range, and then we have 3 right here. It's sort of like K, but it doesn't matter. Print I. Oh, I'm not sure about it. Print I, and then this should be for X. For the line for bar in range 1 and 3 is executed in 3 times. For J in range 1, 2 is executed n over 2 times for each iteration of the outer loop. Will make it run the sort of n, excuse me, over 3 times n over 2, which is in O of n2. Okay, so that's a good way to look at it. Study the following slides for a more detailed line by line analysis of the calculation of the runtime complexity. And it goes 10. I do want to go back and I do want to write this. And so it's the same thing. So for I and range n, no, 1 and 3, negative. And then for x and range 1 and 2. So plus 1. Right. Hello. You said what? I had put some coke on it and then unrested it a little bit. That's what I. That's when I used the mache to crack over the coconut. You just gotta put some coke on it. It'll de-rust it or unrest it, however you say it. You could bring me the mosquito spray. Man, and 12 gonna print lane, lane, lane. That's already seen this. Alright, one. Wow. Wow. Mm, right. Pi. After. Rotate. Range. Var. Sum. One. Thank you. Thank you. Shit. The one that I had. Yeah, if you want it to be good, you can eat it. That depends on if you want to eat it or not. I would eat it, but would you eat it? No. See, we different. I would eat it. Smoothie, huh? You about to take a shower? Rose still sleep? Okay. You gotta put on this mosquito repellent, boy. That will bite your ass up in a heartbeat. All right. So for so for so var so for var, while var is less than n, which is true, when it's less than n, print pi, and then it says for the elements in range var, we're gonna sum this one, two, four. We're gonna multiply by so so while var is going to go from two to we go to eight. I want to see print. I was thinking of print bar. Let me see what. While one is listening, while bar is listening in print pie. And pie prints one, two, three, four times. And then for J in range, if the, for the elements in the range bar, so this thing, I get 16. Six, two, four, six. I'm not too sure on that one, but no, I can't move my screen. I'll just wait, I guess. Detailed step-by-step analysis of the code. Here we provide a more summarized version. The outer loop here runs log of n times. In the first iteration of the outer loop, the body of the inner loop runs once. In the second iteration, it runs twice, and so on. And the number of executions of the body of the inner loop increases in powers of 2. So if k is the number of iterations of the outer loop, oh, okay, that makes sense why I went to 16. Okay. The outer loop here runs log of n times. In the first iteration of the outer loop, the body of the inner loop runs once. In the second iteration, it runs twice, and so on. The number of executions of the body of the inner loop increases in powers of 2. Of course, I knew that. So if k is the number of iterations, yeah. So number of iterations of that. So Now it's freezing up on me. Well, I'm just watching a video. Jeez. Ah, no. Wow. Damn, where did I put it at? Am I tripping? 3, 4, 5. Wow.